Welcome to today's lesson. In today's lesson, we're going to be looking at variation. So, in particular, today we are looking at direct and indirect, or let me say inverse variation. So, just like proportion, direct variation, uh, both variables increase or decrease at the same time. Or in the same direction, or in the same direction. And under inverse, both variables go in different directions, as one increases, the other decreases. Okay, so the other thing that we're going to look at under variation is the sign of variation. They can represent it, or they can say it's a sign of proportionality, sign of variation, or proportionality is a sign like this. I think it's called an alpha in the Greek alphabet. Okay, so here we are going to look at a couple of examples. Let's say we have a question that says m varies directly to v. M varies directly to v. This is how you write it. And m is equal to 10 grams when v is equal to 5 cubic centimeters. Find a, the value of k. So whenever you remove the sign of proportionality, you replace it with a constant. So the next stage here would be to introduce a constant, and here this is 10 is equal to 5k, and you divide both sides by 5. Here you get 2 is equal to k, and the next stage would be m is equal to 2v after you have found the value of the constant. So the next stage would be to find the value of m when v when V is equal to 20 cubic centimeters. So here you're going to say M is equal to 2 times V, which is 20, and M is equal to 40 grams. And the next question is, find the value of V when M is equal to 4 grams. So you go back again to this equation, you put the value of M, which is 4, and then you write is equal to 2V, and the next thing you are going to divide both sides by 2. And when you divide both sides by 2, when you divide both sides by 2, you're going to get 2 here is equal to 4, and this V is equal to 2 cubic centimeters. Let's look at another example, but in this case it's going to be inverse variation. Let's look at inverse variation. Okay, the question says, given that P is inversely proportional, P is inversely proportional to the cube of or to Q cubed, and that P is equal to 27 when Q is equal to 3. Find P when Q is equal to 4. So I want you to take note, when it's inversely proportional, the other variable is the denominator of 1 on the right hand side, like in this case. Like here we say P is inversely proportional to Q cubed. So the next thing would be to introduce a constant. So when you introduce a constant here, K is multiplied by this one, and you're going to have your equation like this. Then the next thing you say 27 is equal to K over 3 cubed. Here this is 27 is equal to K over 27, and you multiply 27 and 27 to get K. (27) and 27, 14, 4 plus 1, that's 5, 49, 14, 18, here you get 9, here that's 12, and here that's 7, so this is 729, which is equal to K. So now your equation will look like this: 729 over Q cubed. And now we need to find the value of P when Q is equal to 4. So now we say P is equal to 729 over 4 cubed, and 4 cubed is equal to 64, because we say 4 times 4 times 4, this is 16 times 4, and here you get 64. So we say P is equal to 729 over 64, and we can use a calculator here. We can use a calculator. I'm just going to get my calculator now. Okay, let's just wait a little bit. Let's just wait a little bit. Hopefully my calculator will be able to open now. Okay, so we say 729 divided by 64, and you get your answer is 11.39. 11.39. Okay, let's go back to our question. So we say P is equal to 11.39, which is equal to approximately 11.4 to three significant figures. Okay, so that's all I had for you in today's lesson. Thank you so much for watching. I will see you in the next lesson.